Right, I'm Bill Pulford. I'm marked on there, Head of Data Acquisition and Scientific Computing at the Diamond Light Source. I'll say more about these a bit later on. Just to say, my claim to fame within networking is that in 1983 and 1984, all those years ago, I probably produced one of the earliest local area networks in the country at a large facility, based on a thing that nobody had ever heard of called Cambridge Ring. And it worked, and it was used for quite a long time. But because of that, and because during that time I lost my hair pretty much, I decided I'd be thereafter a user of any technology that actually fits the bill. So here I feel like a complete fraud, but nevertheless, I will explain what it is and what we do. So I'm going to put this into 3 linked contributions. I'm going to have to go fairly quickly through this, so I invite you to ask me questions afterwards if there are things I haven't successfully conveyed. First, what is Diamond Light Source? This you really need to know to understand the rest of it. Second, a European project called PANData, which is yet another European initiative. Everybody knows there are about 3,000 of these, and you actually need a sort of directory of them. It's a good one. And finally, Moonshot, which is very interesting for us, as I'll show. So what is Diamond Light Source? Diamond Light Source is the largest UK investment in a scientific facility for 40 years. It's built in 3 phases, and when all the money is spent, we will have spent 462 million on this thing. I'll explain a little bit of what we do a little bit later on, but it's one of the very few projects in Britain that's actually arrived on time and under budget. Not me, I didn't have any, I spend it when I see it. Right, what's it used for? All of those things. So it's basically fundamental research. If you think about it, it's using X-rays, and you can think about it as an extremely powerful super microscope. So anything you can zap with X-rays, you should be able to see its the microstructure of those facilities. I'll go on a little bit further and examine some of these things. So it can look at things down to 1/10 of an angstrom. That's 10 to the minus 11 of a meter. So it looks at small stuff, it looks at big stuff, it looks at intermediate stuff. So just 3 separate slides here, which indicates the areas in which we work. In fact, we probably work at pretty much every area of scientific research that you can imagine. For example, these are proteins. Look at why hip joints get rejected. That was important work. We saved a lot of people pain doing that. We looked at what goes on in your stomach. That was essentially to stop you having celiac disease. If anybody's ever had it, you don't want it. And we worked out why. I haven't got time to go into many of these things, but I can go into more detail later if you need it. Engineering, so we can find out that was an Indian piece of casting aluminium at the time, worked out how it functioned. Then understanding corrosion, pharmaceuticals, tunable polymers, that's quite interesting. You don't hit them, they go boing, but nevertheless. And organic photovoltaics. And finally, new materials. These are very beautiful. You know, what you're trying to do is to find materials that we can use in future and exploit, and hopefully earn lots and lots of money. Some of them we do. I mean, this is the thing on the right there is a structure of a molecule. And what you tend to do is you put other atoms and make them react when they get close together by enclosing it in that sort of thing. It's dead clever, actually. Right, how's the light produced? I mean, this is just very simple. You accelerate electrons in a big circle, whiz, 303 giga-electron volts, if you need to know that. It goes round, accelerates, then into the outside, it goes round at this constant 3 GeV. And every time it goes round a bend, it produces X-rays, which goes down these tubes. And each one of these things here, has an experiment on the end. Currently, Diamond has 22 of these things running, and it will, in 2017, have 32 separate experiments, one on each of those ends of those beam lines. From the top end, okay, it looks like that. So you can see the structure. It goes whiz, round, and down. And that thing here, which I shall blow up in a minute, is called a beam line. And that is where the experiments actually do their data analysis and collect data. And what I was going to concentrate on is these things here. We can talk a lot about submitting proposals, doing things and connecting with websites. But in the end, some poor person has to come in and log into a computer and actually collect their data. And this is high interest because at the same time as doing all of this, I was responsible for, this is what we do, sorry, I will just forgive me for that. I'm responsible for this lot up here. I'm the head of these software developers. So we must provide facilities for users to collect those data and do everything they need and using flexible capable tools, and then leave Diamond having evaluated their data quality. So they all leave extremely happy, we hope, and look to come back and remember it to their friends and all sorts of things of that sort. We live in hope, and sometimes it works. But the one thing they perennially whinge about is logging in. They absolutely hate it, and they hate it still as much as us. Because we actually have had what we've called a single sign-on facility since 2007. So everybody user who comes has a username and password that they use to log in. And they all hate it because they can never remember it. So we put facilities so they can keep on remembering it, etc., etc., etc. But that has given us a world lead. No other facility in the world, actually, scientific facility in the world, actually has that. And we can keep their data in a nice way so they can always come back to it, etc., etc. So, and just as an indication, we had, well, you can see that, I'm not going to go through it. A lot of people came, and we have essentially 5,000 different experimenters came in during the year. And during that year, they collected 228 terabytes of data, all of which is stored under their usernames and passwords. We try and think forever, but for at least 5 years. So essentially, this single sign-on is awfully important to us. And then, in Europe, there are quite a large number of other facilities which do complementary research or do research alongside us. And we did an analysis of the number of users who came to our facility who also came to other facilities. And for example, a very big facility in France called the ESRF, I used to work there too, so I have an interest, and it has 739 common users between we and they. So in other words, people who come and do their research in France also come and do their research here. And the notion was, not only do they log in, although I'm quite interested in that, they also want to come and submit proposals for doing experiments. Bear in mind that the service is free at point of use for all UK academics, so it's free. But they have to submit proposals, their reviews, evaluate samples, schedule, all of that. And that is all controlled by the fact that they have a single username and password, and they use that to submit proposals and to log in and do the whole thing. And this is turning out to be extremely important to us. I think you can probably imagine why. And now we go on to the future. Increasingly, experimental visits, or experiments, are not single experiment based, but they're part of a huge project. For example, examining the structure of a ribosome, or working out all of the things that are associated with ferromagnetic materials, or all sorts of things like that, start as an idea, and the people who have this idea want to go and do their research appropriate instrumentation. They might not just always want to come to Diamond, they want to do things like nuclear magnetic resonance, they might do electron microscopy, all of that stuff. But how do they connect together their data so they can actually use the output of one experiment and feed it into the input of the next experiment? And this is the sort of thing we're arriving at. So the overall structure, then you submit experiment processes, experiment proposal to Diamond, having that as simply part of that. You have a review process. Then you have a sample production facility. If you're looking at, for example, at proteins, you actually have factories, the big machines actually, which produce 800, 900, 1,000 samples that they all bring at one time. And you need to know where they came from. It's all logistics. The whole thing of this is logistics. Who the data belong to, where it's going to go, where it's going to go next. And so they have lots of visits. They want to look at remote resources. So again, I will suggest that when you use remote resources, I'll come on to this a bit later, you want to do it transparently. You do not want to stop and log in again to something else, and then log in again, bring it all back. So you want to streamline the whole process. This is what makes us very happy. We also have a thing here called an ICAT. So all of the data, all of those 228 terabytes, are stored essentially, it's a large tape library. And it's stored securely under the names of the people who perform the experiment. Then, of course, we hope they do wonderful experiment physics, they're very happy, they do remote data analysis, and they submit proposals into publications. All of it, again, tries to be linked. This one's a bit of an interesting one for the moment, but everything else is what they try to do. They also might go somewhere else, they might go to a totally different facility in France or Germany, or Lund, for example, if you're in Sweden. Okay. Just as a, everything must be transparent as possible. As I say, I'm a gross user of networking, I don't write it anymore. So there is this European project called PANData. I won't go to all of this, but the whole point is a common data policy, protocols. In other words, when you're moving data between A and B, you need to understand what you're sending. Definition of common standards for data formats of files. We use a thing called Nexus, where you actually write in the file enough information for anybody picking it up at any point to perform the appropriate analysis. Interoperation of data analysis software across the facilities, integration, cross-linking, and the last thing, which is also quite interesting, is that OpenAir, ORCID and OpenAir, are also the publishers are also quite interested in using this, because we are seeking to establish, say it now, a single user sign-on for all of the scientists in Europe, of whom there are at least 30,000. Because the publishers themselves are in grief because they can't actually uniquely identify the authors of the papers. And so they're quite interested in what we're doing in this area. So there's all sorts of people here, SLAIS France, Italy, us, France, Germany, Barcelona. I was saying I come back to the single user sign-on. There was originally a project part of this called Umbrella. And I had the joy to be the coordinator of the first enabling part of this, called PANData Europe. And I had the joyous opportunity of actually choosing which technology we used and actually to perform the data, the single sign-on. There was, however, a parallel project going along. We chose it, and this is Umbrella, Project Umbrella. This is, I'm afraid to say, based on Shibboleth and SAML 2, but given that we're academic, we sort of almost got chucked into it from the bottom end up to actually do it. And so far it worked very well. The problem we had is that in the recommendations I said, right, okay, we should use it, it's available, it avoids us inventing the wheel. But it's no good just logging into websites with this, you've actually got to log into those machines on the beamline and actually collect data. So we've got to do that. Just at that moment, Project Moonshot burst out of the big nothing to say, right, well, that's what we're trying to address. And as it just happened because I was very aware of it middle of last year, but November, we ran a feasibility study before I wrote this recommendation to see whether we would actually go forward with this. I actually had a contractor in last November, some people might remember, a name called Brian Abrams. And it was purely a feasibility, but it didn't go any further than that. But in the time, we actually did it. And you can actually use an Umbrella ID, which is Shibboleth based, go to a Linux machine and log in. And I used that as a gateway process in order to go any further, because otherwise it wasn't interesting otherwise. Another thing which I add, which this is just a techie thing, we protect all our internal services by a thing called a CAS server, Central Authentication Server, which I love to death because it means you don't have to mess about with all your code inside, because it's all done on the CAS server, and it means you can generate very happily and use that as essentially your login portal. So the potential future authentication strategy, this is what we're setting up. I don't go into great detail, but Moonshot fills this bit over here that was absolutely key to us. It enables you to go to a Windows machine, Linux machine, or it prompts you to do that, but I'm confident it will, and log in with your single user sign-on ID. The current recommendation for choosing that single sign-on is that the user themselves will choose it, but we fully expect them to use their email address pretty much, and then use it. a password that they will remember, which stops them whinging at me bitterly, because I've already got holes and bruises and things from this sort of business. So, and the session, again, purely looking at more detailed Moonshot, expecting we're installing a PAM stack actually on Linux machines. I understand that Windows machines are pretty close to, and Macintosh machines. So you just log in with your email address, or what I'm expecting people to choose, sure. And collect your data, and of course, because the authentication does actually provide you with a link to your local standard UID, GID, all of the data that we've already collected will still work once we change our usernames, passwords to this new system, which is very, very important. So, okay, I'm going to go through these very quickly. Current systems. One thing we do have, I guess I just bring this up for people to ask themselves questions, or eventually ask me questions, is how long a user can they actually access the facility? At the moment, in fact, they have an access for 2 years, but in fact you may actually wish to be a little more subtle about this. So we may have to extend this, perhaps, I would say, X509 certificates. Persistence and caching is an interesting one, because most of these technology we've heard about so far won't necessarily resist interruptions to the network service. You really need that. So there needs to be some way in which you can cache these things locally. Okay, must support Windows, Macintosh, Linux, should be simple, etc., etc. I think if you were writing these, you'd say it yourself. One thing we had recently, we had a review, and those people who reviewed us said, if you were choosing a system for your login, you would choose, they said, oh, you want EduRoam. If for those people who don't know, EduRoam enables you to go anywhere and log into a wireless-only network using essentially your email address, is what it comes down to be, or rather your credentials are provided by your university. And happily, Moonshot also uses pretty much the same technology. In fact, I suspect Reese, the man who knows far more about it than I do, will say, yeah, okay, you probably have them on the same system, you don't have to do anything, you know. Right, that for me is enough on networking, because I don't know anymore anyway, so, you know. Just to say what we do, this is an interesting one. This is for proteins. The structure of a protein, this has perhaps 15 million molecules in a protein, and you need to establish the three-dimensional structure of this in order to, I don't know, find out how a disease works, how to cure things. In my day, I did this when I was a long time ago, and it took me 8 months to produce one of these. Rather depressingly, but I suppose I should say very happy, you can do this in now 5 minutes, courtesy of all of the things we've put into place. Another thing, again, some of our very, very large data requirements are associated with a thing called tomography. That's essentially where you're putting slices through the material, and then you're reconstructing into 3D. So I think I'm good, actually. I think I'm going to make it. Good. Notice that it actually takes 6 hours, or can take 6 hours to produce one image, and you can change it, but it does take you a long time to do the reconstruction of a thing called a tomograph, to produce a three-dimensional rendering of the object that you had. Now, by using that sort of grid diagram, the diagram I had earlier, which showed you links to all the facilities, you could, for example, replace some of the local processing with a remote access to a very high-speed remote resource. And the idea is to do this, something like that, in 2 minutes, not 30 minutes, simply by allowing you to access remote resources. And the key point of that is it must be transparent. There's no stopping and humming and hawing and say, oh, log in or do anything else. It must be transparent. Again, part of the federating or linking local resources to remote resources. This is a bit of fun. This is another one. This guy called a spider catches the hare. The person who put this on, this is only a test sample, a bit rough for the spider, unfortunately. It didn't survive this because it was put into an X-ray beam, but it was a bit rough on it. But one of her locks of hair, one of her hairs fell on it. But if I do that, that's what it looks like if you actually render it. Again, that was done on our site using our local clusters, using all of the infrastructure we put into place. Poor old spider, but never mind. Finally, oh, sorry, I did it again. Where are you getting up to look, don't you? I want to go to the next slide. Oh, there we go. Finally, the vision for the future. I think we probably all have exactly the same vision for the future, pretty much. We were all asked to write it down. You do your facility access, high power cluster, industrials, academics. This could be universities, site, ORCID, open air. You want to be able to get the publishers also on board with this, so you can link your authors to your experimenters, which is one thing this promises to do. And finally, thank you. Indeed, I actually have Roland Hedberg on this too, because of the PY SAML stuff that we did. And I thank everybody else, and I also thank my colleagues at Diamond who made this possible. But thank you all.
Brilliant. Thanks, Greg.